We now have in front of us our worksheet for the hour. Let me begin by asking you to make sure we're on the same page where it's saying Objective 3, identify and use the limiting reagent in a reaction to calculate the maximum amount of product produced and the amount of excess reagent left over at the end. There is a side 1 and a side 2. I just want to be sure we're all on the same page looking at the first side. I'll read for us the first of our story problems. It reads, vanadium 4-phosphide is produced from its constituent elements. The term constituent simply means it's the elements that it's made up of. To begin with, I like to point at our product and think about charges as I'm producing. Vanadium is a symbol V. It carries a +4. The Roman numeral tells me. Phosphide is the symbol P, and it's a -3. When I crisscross, I get V3, P4. The elements that it's built of would be vanadium and phosphorus. This pattern of chemical change would be known as a combination. To balance it, I'll put a coefficient of a 3 in front of the vanadium and a coefficient of 4 in front of the phosphorus. 3 moles of vanadium reacts with 4 moles of phosphorus, producing V3P4, vanadium 4-phosphide. Here's our balanced equation with the stoichiometric ratio of 3:4:1. Letter B asks, how many grams of vanadium 4-phosphide can be produced from the reaction given 175 grams of vanadium with 100 grams of phosphorus? Since we are given information about both of the reactants, we need to work both sets of stoichiometry problems to determine the maximum yield. We'll begin with the first reactant as 175 grams of vanadium. I'll get our 3 parentheses ready, our divide, ratio, multiply, where our target is our product, the grams of V3P4. I'll also set up the second stoichiometry problem so we can see its journey. The second reactant of phosphorus was given as 100 grams of P, setting up my stoichiometric parentheses, targeting the product, grams of V3P4. So now as I look at the journey, we'll divide, ratio, multiply, our 3 steps. First thing we'll need to do is find the vanadium's molar mass. Now vanadium has an atomic weight of 50.94. I'll put that in here as 51. So 1 mole of vanadium with a molar mass of 51 grams. Moving to the heart of our problem, our want over given stoichiometric ratio, I see that every 1 mole of our product, V3P4, requires 3 moles of vanadium, a 1:3 stoichiometric ratio. In our third parenthesis, we will need the molar mass of our product, and let me hit for that. Vanadium we said was 51, and I'm counting 3 of those in the formula. Adding to that the phosphorus, who weighs 31, but there's 4 of those combined, I come up with 277 grams as our molar mass in every 1 mole of the product, V3P4. Starting with 175 grams, I'll divide by 51, the molar mass of vanadium. I'll multiply by 1/3, so times 1/3, and multiply by that molar mass in the third parenthesis, 277. This yield looks like 316.83 grams of vanadium 3-phosphide. Same idea, but starting with the second reactant, 100 grams of phosphorus. I'll set that up in my first conversion using the molar mass of phosphorus as 31 grams. The stoichiometric ratio, the heart of our problem, we have 1 mole of V3P4 set over 4 moles of phosphorus. This time our ratio is 1/4. The third step will be identical to up above, 277 grams of V3P4 in every 1 mole. The molar mass is identical for both problems. Starting with 100 grams, I'll hit 100 divided by 31 times 1 divided by 4 times 277. And this story problem works out to 233.39 grams of vanadium 4 phosphide. The maximum yield is the smaller of our two answers, so I will circle that and label it as my maximum yield of our product, B3P4. The other thing I'll let you know is that phosphorus would be called the limiting reagent, and vanadium would be called the excess reagent. Knowing that the limiting reagent determines the maximum amount of product, once I find that smaller of the two answers, I find that reactant that gave me that, the phosphorus was indeed the limiting. Part C is a brand new part we've not seen before, so pay special attention as I model how many grams of the excess reagent are left over unused. Friends, this will involve yet another stoichiometry problem, where the limiting reagent determines out of the 175 grams of vanadium we started with, how many were actually used, so we can find what was wasted, left over at the end of our reaction. I'm going to start, as we always should, using the given 100 grams of phosphorus as the limiting reagent. Always start with the limiting reagent. What we then want to determine, using a three-step stoichiometry problem, we'd like to know how